So first we are going to write down what the problem gave us and what variables we should use with them. So the problem gave us that Emma is traveling at 50 miles per hour, that Zach is traveling at 35 miles per hour, and that we are trying to find the rate at which the distance is changing between them. And so we need to find that. And then it also gives us that time equals 5 minutes. And in order to find the rate at which it's changing, we need to find all the sides. So we also need to find x, y, and z. Next, we are going to draw a diagram so that we can visualize the problem. So if Emma is driving 50 miles per hour going west, and Zach is driving 35 miles per hour going north, then this was what our triangle would look like, and we're trying to find the rate at which these two vehicles are changing. So since our units are given to us in miles per hour, we have to change miles per hour into first miles per minute, and then we multiply it by the 5 minutes to see how far the distance is. So for Emma, x would equal 50 miles in 1 hour, and in 1 hour there are 60 minutes, and then the time is 5 minutes. And so this would equal 25 over 6 miles. So that's how far this distance is. So x equals 25 over 6 miles. And we're going to keep it in fractions so that it's easier to solve at the end. We have to do the same thing for Zach. So y would equal 35 miles in 1 hour. In 1 hour, 60 minutes. And it's 5 minutes. So that would give us 35 over 12 miles. So that would go here, that's this distance. So y equals 35 over 12 miles. Next, we have to do Pythagorean theorem to find out what z equals, so we can eventually find dz dt. So it's going to be x squared plus y squared equals z squared. And you're going to go ahead and plug in the numbers that you found over here. So x was 25 over 6 squared, and y was 35 over 12 squared. And then you have z squared. So you're going to take square root of both sides, and then you get z equals 5.08607 miles. So that's what this distance is here. And so then we're going to use that to find the rate at which the two distances are changing. Okay, so lastly, we're going to use Pythagorean theorem again so we can find dz dt. So we're going to do x squared plus y squared equals z squared. And instead of just plugging it in this time, we're going to take the derivative. So it's 2x dx dt plus 2y dy dt equals 2z dz dt. And since all of these terms have 2, we can go ahead and cross out the 2's. And then we're just going to plug in what numbers we got earlier for our x's and what problems that we got earlier for our dx dt and dy dt that they originally gave us. So x we got as 25 over 6 miles times dx dt, the problem gave us 50 miles per hour, plus the y we found was 35 over 12 miles, and it gave us 35 miles per hour. And z we just found was 5.08607 miles, and so we're looking for dz dt. And once you solve this all out, you get dz dt equals 61.0328 miles per hour, but the problem asked you to round to the nearest whole number, so 61 miles per hour is your answer. So overall, some tips are just to write out your variables and what numbers they give you at the beginning and what you're looking for. Draw out a diagram so it helps you visualize what you need to find. And then you solve individually for x and y. Use Pythagorean theorem to find z, and then you take the derivatives and plug it in and you get your end answer.